At the end of the last video, we asked where would the center of mass be if we had a system of more than 2 point masses. So let's consider a system of 3 point masses. A, which is at 1, 0 and has mass m. B, which is at 7, 0 and has mass 3m. And C, which is at position 5, 3 and has mass 3m. How could we calculate the center of mass of this system? We use the same equation as before, except now we have two-dimensional vectors and we have 3 points. So the equation becomes, we can then go through and substitute in the numbers to find the center of mass for this system. So once again, our m's cancel out here. So as we can see, it's 5 in the x direction plus 1.5 in the j direction, which makes our center of mass over here. As we can see, it is central to all the points, but it's closest to C because C is the heaviest. Now, just note that the center of mass is a position and it has units of meters, not kilograms. So even though it's got mass in its name, it's actually not a mass, it's a position. Now, we can actually generalize that formula that we've got here for any arbitrary number of point masses. In this case, it would become the center of mass is equal to the sum of each of the individual masses position multiplied by its mass divided by the sum of each of the individual masses. So note I is our index here, so we do this for each I. So if there's 3, we go from I equals 1 to I equals 3. If there's 10, then you go from I equals 1 to I equals 10. So n is the total number of masses that we're considering. That's how you deal with center of mass if you have discrete point masses. But the question is, what happens if you have a continuous fluid or a continuous object and you want to know its center of mass? Stay with us in the next video to find out.